Now that we simply went over the relational model, without going into the details, we will talk about how we can retrieve data from a relational database. By the end of this video, you should be able to describe what data retrieval means, explain the purpose of SQL, and create simple select queries. Data retrieval refers to the way in which data desired by a user is specified and retrieved from a data source. Note that in this course, we are using the term data retrieval in two ways. Assume that your data is stored in a data store that follows a specific data model, like, for example, the relational data model. By data retrieval, we will refer to the way you specify how to get the desired data out of the relational data store and the internal processing that occurs within the data management system to compute or evaluate that specified retrieval request. Now let's see the query specification happening using a specific language called Structured Query Language, or SQL. SQL is the ubiquitous query language when the data is structured, but it has been extended in many ways to accommodate other types of data. For this lesson, we will stick to the structured aspect of the language. You should know that SQL is used in classical database management systems like Oracle, as well as modern distributed big data systems such as Spark in the form of Spark SQL. Let's work now with an illustrative example. Our schema for this business has three relations or tables. The first table lists these bars, their name, address, and the license number of the bar. Notice that the attribute called name is underlined because it is the primary key of the bars relationship. Recall that primary key refers to a set of attributes, in this case just name, that make a record unique. Note that the relation bars with the attribute names within parentheses is the same as the table shown on the right. We will use both representations as we go forward. The second table, called beers, lists the names and manufacturers of beer. Not every bar sells the same brands of beer. Even when they do, they may have different prices for the same product because difference in establishment costs. So, the sales table records which bar sells which beer at what price. The most basic structure of a SQL query is a select from where clause. In this example, where we are looking for beer names that are made by Heineken. So we need to specify our attribute, which is our output. In this case, the name of the beer. The logical table, which should be used to answer the query. In this case, beers. And the condition that all the desired data items should satisfy, namely the value of the attribute called manf is equal to Heineken. There are a few things to notice here. So our query is select name from beers where manf equals Heineken. First, the literal Heineken is put within quotes because it's a string literal. Remember that, in this case, the string is supposed to match exactly, including the case. Secondly, if you go back to the data operations we discussed in Pandas, you will recognize that this form of query can also be represented as a selection operation on the relation beers with the condition on the manf attribute, followed by a projection operation that outputs the name attribute from the result of the selection operation. So, the selection operation finds all tuples in beers for which the manufacturer is Heineken, and from those tuples it projects only the name column. The result of this query is a table with one single attribute called name. This would be a column in Pandas or a series object. We illustrate some more features of SQL using two more example queries. The first looks for expensive beer and its price. Select distinct beer and price from cells where price is larger than 15. Let's say we consider beers to be expensive if it costs more than $15 a bottle. From the schema, we know that price information is available from the table called cells. So the from clause should use cells in this case. The where clause is intuitive and specifies the price to be greater than 15. Now, notice that the cells relationship also has a column called bar. Now, if two different bars sells the same beer at the same price, we will get both entries in the result. That's not what we want, regardless of the multiplicity of bars that have the same price for the same beer. We want the result just once. This is achieved through the select distinct statement in the first row, which ensures that the result relationship has no duplicates. The second example shows the case where more than one condition must be satisfied by the result. In this query, the business must be in San Diego, and at the same time it must be a temporary license holder, which means the license number should start with 32. As we see here, these conditions are put together by the AND operator. Thus, this query will pick the third record in the table because the first two records satisfy the first condition and not the second condition. One can also place a limit on the number of results to return. If our database is large and we need only 5 results, for example, a sample to display, we can say limit 5. The exact syntax of this limit clause may vary between database management system vendors or even in Python. As a summary, SQL is the standard querying language for structured relational data, and it resembles Pandas data frames, although it can provide more operations. SQL allows for joining and other operations in addition to the simple data selection queries we focused on in this video, but we will not go into the details for those operations. And we'll show you a notebook next, how to use some of these selection queries in the context of Python Jupyter Notebooks.